Game Theory Class 4 Video 2. In this video we're going to introduce the notion of Nash equilibrium. Nash equilibrium are very important. They're one of the central concepts and one of the most important developments in game theory in modern history. Before I give you the definition of a Nash equilibrium, I just want to tell you a bit of background about the person for whom they're named after. So this is John Nash. And you might have actually heard of him. He was the subject of a movie, A Beautiful Mind, which is a movie about a mathematician, and it's actually quite interesting. It's a bit sensationalized, but it's somewhat biographical. So John Nash lived from 1928 to 2015. He was a mathematician. And he was known for a bunch of different things. So he's known for game theory, but also he did a lot of work in a subject called differential geometry. And stuff called PDEs, but that's not too interesting. He received a Nobel Prize in 1994, and he received it for his graduate work. Which was on game theory. I mean, he did his graduate work many years before 1994. He was a graduate student many years before that, but it just took a long time for the world to realize that his work was actually very good and very influential. I will say he received the Nobel Prize in economics. He received the Nobel Prize in economics because there is no Nobel Prize in mathematics. There just doesn't exist a Nobel Prize in mathematics. So they gave him the Nobel Prize in economics instead. This is because game theory has really greatly shaped a lot of economics. Later on in life, he received a mathematical prize. So in 2015, he won the Abel Prize, which is sort of like the mathematician's version of the Nobel Prize. It's arguably like the most prestigious mathematical prize there is. Okay, and he and his wife flew to Norway to pick up this prize, and they had a nice time or whatever. They picked up the prize, and then they came back to New Jersey where they lived. So John Nash and his wife, they both died on the car crash. In a car crash back from the airport, from picking up the Abel Prize. So they flew back into New Jersey to go home after picking up the Abel Prize, but neither of them were wearing a seatbelt. They got in a car crash and they both died. A car crash. After picking up the Abel Prize. Okay. So wear a seatbelt. Okay. I'm not saying things would have turned out differently for John Nash, but it's good advice in general. Wear a seatbelt. Okay. That's enough non-mathematics. Let's talk about mathematics. So what is a Nash equilibrium? A Nash equilibrium is a pair of strategies that are best response to one another. Okay? So it's a pair of strategies like AX, where A is the best response to X, and X is the best response to A. So I could write this algebraically like this. I could say AX is a Nash equilibrium if the best response for player 1 if player 2 plays X is A, and the best response for player 2 if player 1 plays A is X. This is sort of like the algebraic way of writing this. It's a bit abstract, so there's also a more qualitative description of a Nash equilibrium. So equivalently, a Nash equilibrium is an outcome where neither player can unilaterally improve their payoff by changing strategies. So what I mean by this is, it's a situation, an outcome, in which no player has an incentive to change their strategies. Okay? Like, it's impossible for me to improve my payoff assuming that my opponent does not change their strategy. So, some notes about Nash equilibrium. Okay? Nash equilibrium are not necessarily the best outcome. Whatever best means. Okay? They're not necessarily the best thing to do. The trouble is, sometimes you get stuck in a Nash equilibrium. You shouldn't really think of Nash equilibrium as like the best outcome. You should think about it more as like a stable outcome. It's an outcome in which no player wants to change. They don't have an incentive to change. But that doesn't mean that there's not a better outcome out there. Okay? That might sound contradictory, but once we start doing examples, you'll see what I mean. It's an outcome where no player unilaterally wants to change. But that doesn't mean that there's not a better outcome for everyone possible. It just means that no player can get to that better outcome unilaterally. There would have to be some sort of coordination in order for the players to get to the better outcome. So by all means, Nash equilibrium are not necessarily the best outcome. Another thing I want to note is some games don't even have Nash equilibrium. Some games don't have any Nash equilibrium. I'm just going to use NE to denote Nash equilibrium because it saves me writing some stuff. And similarly, some games have more than one. Some games have more than one Nash equilibrium. So really anything can happen with Nash equilibrium. Sometimes you have a game which doesn't have any, a different game might have one, a different game might have more than one. And this is all okay. Okay? I personally find it helpful to think of Nash equilibrium as stable outcomes. They're outcomes where no player has an incentive to change what they're doing. So if you imagine playing the game iteratively, like again and again and again and again, maybe you'll fall into a routine. And a Nash equilibrium is like one of these routines where nobody wants to change what they're doing. But that does not mean that the routine you're in is the best thing to be doing. In the next video, we'll do some examples of how to find Nash equilibrium, but that's the end of this video.